Hi, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students who are studying functions and relations. It's from the summative package and it's question number 12. It says the population of a town has increased at an annual rate of 1.5% since 2000. It had a population of 16,000 in the year 2000. Write an equation that models the growth in population of the town since 2000. Describe each part. Okay, so this is an increasing function. And because it's increasing at a certain percentage, I know that it's an exponential growth question. So in general, and I'll use P for population, this is what it would look like. So the population is calculated from the original population times some exponential base to some exponent. So this is sort of a generic look at what the equation might look like. And now let's put in some actual values. So the population is the original population, which was 16,000. And then its growth, that's why you see 1 plus. And the growth rate is 1.5%. So I'll set that up like this. So as a percent, it's 1.5. So as a decimal, it's 1.5 over 100. And then the exponent is time over now the annual growth rate. So that would be 1 as long as I say that t is in years. And we need to specify since 2000. So we have to calculate how many years it's been since the year 2000. That's what would go there. So this is my equation. Now I could clean it up a little bit and write it as 1 plus 0.015. Oh, I lost my decimal. To the t. And then maybe this is what I'll describe. So 16,000, that's the original population, meaning in the year 2000. So in the year 2000. T is time in years, so I kind of already got that. The reason why it's divided by 1 is because it is an annual growth rate. So this happens every 1 year. So 1 is the, I usually say the half-life period, but it's not a half-life. So 1 is the exponential period of growth. And then inside of the bracket, we have two pieces, the 1 and then the plus, and then I guess this. So the 1 is because 100% of the population originally matters. So the 16,000 original number is incorporated into my math. It's growth, so that's why we have a plus sign. And then the growth rate is by 15%. So this 1 plus 0.015 is that it's growing by 15%. So the 15% is the new population, and the 1 represents the original population. Okay, so that's my equation, and hopefully that makes sense. So let's look at what we have to do with that equation. It says use your equation to determine the population in 2010 and in 2020. So let me write the equation. Oops, I actually know PO, so let me fix that. So the equation would be P equals 16,000 times 1.015 to the T. And again, T is in years. So in the year 2010, so in 2010, T equals 10. So the population would be 16,000, 1.015 to the 10. And then I just have to be careful to calculate that using order of operations. And I get a population of, and I'm going to round it to the nearest whole number because I don't know what 0.6 of a person is. So I'm going to say 18,569. And similarly, the population in the year 2020 means that I need to use t equals 20. Sub that into the equation. So the population is 16,000 times 1.015 to the 20. And again, calculate that properly, rounding to the nearest whole person. I'll say 21,550 people. Okay, so that's part B. And then part C says, when will the population double? So here's my equation, 1.015 to the t. So if I want the population to double, If it starts at 16,000, then I'm looking to know when the population will be 32,000 because that's double. And there is a shortcut I could take, but I'll show you that in a second. So I'm solving for the exponent t over here. So the first thing I need to do is isolate the base. So I need to divide both sides by 16,000. So over here I get 2, and then it's to the 1.015 exponent t. So the shortcut is that if I want something to double, it doesn't actually matter what the starting amount is. If I want it to double, I want it to look like this, so whatever the base is. So eventually I want to have 2 based on whatever I started with. So in a way, it's like I'm imagining that I start with 1 and I want it to be 2. Or if you want, I want it to be 200% when it was originally 100%, and it really doesn't matter what the original amount was. But whatever, we eventually get here. And now, if you've seen my video for question 11, this is where I'm not 100% sure how your teacher would have done this in class, so I'll show you both methods. One method is to guess and check. Um, Now, the important thing about guessing and checking is that you have to actually show your guesses, your checks, and your logical progression. So I'm going to guess some values for t and see how close I can get to an output of 2. And let's be smart about this. When I go to the questions I've already done, I see that if t is 20, I'm only at a population of 21,000. So let's go higher than 20. Let's try t equals 30 and see what we get. So 1.015 to the exponent 30, I get 1.56, so not high enough. Let's try 40, and I get 1.81, still not high enough. Let's try 50, and I get 2.11, so I'm too high. So let's go in between. Let's try 45. So you can see that all I'm doing is I'm trying different numbers and adjusting my guess according to what results I've seen. So I'm at 1.95, so we're getting close. I need to be a little bit bigger than 45. Let's try 47. 1.015 exponent 47. I get 2.013, so 46. And you can get as precise as you want, of course, depending on how much time and effort you want to put into it. I get 1.98, so that's pretty darn close. So I'm going to say that t is 46, and so that would be in the year 2046. That's when the population would double. And that's using the guess and check method. So I'm going to show you the other method, and now this method, you know, here's the problem with this other method, is that it's based on something you haven't learned yet and you won't learn until grade 12. So sometimes I don't like introducing things without explaining them clearly, but I can't really explain this in the period of time we have together here on YouTube. So let me just explain what it is. There's a button on your calculator called log, and log is short for the word logarithm. And logarithm is a mathematical thing which is basically the inverse of an exponent. You will study them more if you take grade 12 advanced functions. For now, we just have to know how to use the log button to solve for an exponent. So let me give you the basic structure here. If I have an equation where I have something equals a base with an exponent and I want to solve for x, so I want to solve for that exponent, then I can use my log button like this. X is equal to log A over log B. And it's just press the button, type it in, let your calculator do the math. So the thing to remember if you're going to use this method is that this exponent x is on the base b, and the base is what goes on the bottom of this expression. So over here, to use it, if I have 2 equals 1.015 to the t, and I want to solve for t, then I'm going to use log of 2 over log of 1.015. And again, 1.015 was the base, so it goes on the bottom. And then it's just type that into my calculator. So I do log 2 divided by log 1.015, and I get an answer of 46.6 years. So sometime in about the year 2046, just like I got through guess and check, but this one certainly took me a lot less time. If you're going to use the log method, please make sure that you ask your teacher if you're allowed to, because there is a lot of good math in guess and check, and your teacher might want to see you do that logic. So just double check before you try to use that method, but feel free to use it as a method to check your answer. Hee hee. All right, thanks for watching. See you in the next video.